Hi, my name's Darryl Peterson, and I'm the manager of the Applications Engineering Department here at Micromeasurements. This afternoon, I'd like to take a few minutes and show you a strain gauge application where we're going to put it on this hockey stick. It happens to be one that's used for outdoor street hockey, and this one also happens to be left-handed, but we're going to install a strain gauge down on the handle of this hockey stick so that we can look at the combined loads that we see from hitting a hockey puck or the puck that gets used outside. We're expecting to see some bending loads, and we're also expecting to see some torsional loads on this hockey stick. So what we've decided to do is use one of the Micromeasurements 3-element rosettes for this installation. This one happens to be one that's a little smaller in size, and one of the reasons we selected this one is we wanted it small in size to kind of focus the area of measurement, but we also wanted the small lead wires to try to minimize how much interference we get when we actually take the hockey stick and try to take a shot with it. This is one of the Micromeasurements C5K series 3-element rosettes. If we look down here at the bottom, you can see the part number. This is a C5K-06-S5198-350-39 F as in Frank. And what that basically means is that it's a pre-cabled strain gauge. It's got 36 gauge Teflon insulated wire pre-attached. This pre-attached lead wire is 9 feet long, which would be plenty long enough for us with the hockey stick. And again, it's a 3-element rosette in a 350 ohm resistance. So by using a 3-element rosette, that allows us to solve for our 3 unknowns, which are our maximum, minimum principal strain, and direction. Now, a strain gauge like this requires 3 channels of electronics, and we'll get to that a little bit later, but we'll connect it into one of our data systems, measure these 3 grids separately, and that allows us to calculate those unknowns. So that's the strain gauge. We're going to install it using the M-Bond AE10 epoxy. It's a 2-part epoxy system. It cures at room temperature. It does require clamping pressure, so we're going to put some clamps on it, let it sit up overnight. We're also going to clean the surface. Very important to ensure we get good strain transmission. We're going to start with degreasing it using the Micromeasurements GC6, which is an isopropyl alcohol. Then we're going to do an abrasion step, and we're going to use 220 grit silicon carbide paper to abrade the surface of the hockey stick. Then we're going to clean it with some M-Prep conditioner, which is a very mild phosphoric acid that helps to chemically clean. And then also, finally, clean it with the M-Prep Neutralizer 5A. Then we'll handle the strain gauge, get it installed. Once the gauge is installed and the epoxy has been fully cured, the last step is we're going to apply a protective coating over top of it. And in this case, we're going to use M-Coat C, which is a solvent-thinned silicone rubber. Very easy to put on. Oftentimes, it's good for holding down things like your lead wires on, like in this case, on this hockey stick. It stays relatively soft, so we find it's very popular for customers that are manufacturing transducers where they're worried about affecting the sensitivity of the transducer. You don't have to worry about that with M-Coat C. And also, it has a very wide temperature range. It's good up to about 500 degrees Fahrenheit. So if you had an application that's going to get hot, you might consider using that M-Coat C as the environmental protection for the strain gauge. Okay, so really the first step in this process is to clean and prep the surface of this hockey stick. This one happens to be made out of wood. In general, whenever you start cleaning the surface of a part, the very first thing that you do is degrease. And in this case, we're going to use the GC6 isopropyl alcohol. We have another solvent. It's called CSM3. It's a little more aggressive. Typically, I'd use it on wood, where this works great on other materials like plastics, composites, in this case wood, because it's a little bit less aggressive, and some materials can react to certain solvents. But in general, most things you can clean it with isopropyl alcohol. So I'll just take the cap off and take one of these gauze pads, and I'll fold it and then fold it in half again. I'll just apply some of the solvent into the gauze pad, and then I'll just wipe off the surface of the hockey stick. All we're trying to do is remove any contamination that's on it, maybe from shipping it or from me handling the hockey stick. Again, just kind of wipe off both sides and then discard the gauze pad. I'm going to use this again, so I'll just move it to the side. The next step is we're going to abrade the surface. And what we're going to use is a piece of 220 grit silicon carbide paper. We like to use silicon carbide paper because when it gets wet with some of these materials, it doesn't release its mastic and its grit. So what I'm going to do is tear a piece, that's maybe about 2 inches long, and just fold it over top of itself. And then I'll just start abrading the surface. Anytime you look down at the surface and you see shiny, you really don't want shiny for bonding strain gauges. Shiny means it's reflecting the light and it's smooth. And for bonding strain gauges, we want a little bit of surface texture. I'll sand it that way and I'll just flip it over. And what I'm trying to do is to remove that shininess, create a nice dull finish for bonding. And I think on this hockey stick 220 grit paper is about right for getting that surface prepped. I'm going to take another gauze pad and some more alcohol, and I'm going to wipe that off. Kind of start inside the cleaned area and then wipe out. I'll take it and refold it so I get a clean side and go in the other direction. And just kind of wipe off the edges. So now I've degreased it. I've abraded it using the 220 grit paper. Next step, I'm going to scrub it. And for scrubbing it, I'm going to use what's known as our Prep conditioner. It's a mild phosphoric acid that helps to chemically etch the surface. And I'm going to use a cotton tip applicator. So I'll take the conditioner and I'm just going to wet the surface. I'm going to hold the hockey stick up a little bit, hold it up in the air, wet the surface, and then scrub it. Very important to use the conditioner when you're installing strain gauges on metals. It helps to chemically etch the metal surface. It's also a cleaning step. Some customers will warm it up, and it's kind of like when you're washing dishes at home. It helps to make it a little more aggressive whenever you heat the water up or use hot water to wash your dishes. In this case, I'm just using it at room temperature. But I'll scrub it until the cotton tip applicator comes up clean, and if this one gets contaminated, then I'll grab another one and use it. Once I've completed that scrub with the conditioner, then I'm going to take another gauze pad. I'll use a single wipe down one side, take it and refold it, start about the same location, and go in the opposite direction. The one thing you do not want to do is wipe back and forth with the same surface, because that could redeposit contamination that you picked up. So in this case, we've just scrubbed it with conditioner, and we've got just another couple of steps here, and then we're done with the surface cleaning. So I'm going to take this piece of paper and discard it because it's getting wet. And then I'll locate the blue tip bottle, the neutralizer, and this is an ammonia-based solution. Basically what this will do is it's a final cleaning step, and it will help to bring the pH of the surface back up to an acceptable level. Some adhesives are sensitive to the pH. In general, with the M-Bond AE10, the adhesive, the two-part epoxy we're using, it's really not sensitive as much as, say, a cyanoacrylate is, but in general, you want to finish things up, make sure the pH is at basically a balanced condition, and neutralizer will help to do that for us. So I'm going to take the blue tip bottle, just open it up, kind of flood the area on the hockey stick, hold that up so it doesn't all run off. Take another clean cotton tip applicator and just clean that surface. You'll notice as I do that, it really comes up, you can see very little contamination on that cotton tip, and that looks good. So I'll take that, move that out of the way. discard the top sheet of paper, maybe the top 2 sheets of paper, and basically we're done with the surface cleaning of the hockey stick. Now, the next few steps, we're going to prepare and handle the strain gauge. So that's going to be a little bit different. But at this point, we can take this hockey stick and just kind of move it to the side, and then let's focus on getting the strain gauge prepped and ready. So the next part of this installation is to prepare the strain gauge and get it ready for bonding. And what we like to do is use a piece of glass as a work surface. Great thing about glass is that it's non-porous, so chemicals don't leach into it and leach out later. Also, you can easily tell whenever it needs to be cleaned, and this one does, so we're going to do a little bit of house cleaning. You also need a good pair of tweezers. I like to use these because they have a rounded tip to them. This rounded tip will help to reduce the chance of damaging the strain gauge as we're trying to handle it. So if you're going to be installing strain gauges, you need to get yourself a good pair of tweezers. Just like a good mechanic has a good set of tools, you need a good set of tools for strain gauge installation. And these are some pretty good ones. So as I get started here, first thing I'm going to do is a little bit of house cleaning. I'll take a gauze pad and fold it. Find the blue tip bottle, the neutralizer again, and use a few drops on the surface of the glass. And just wipe that off, because this is going to come in contact with the strain gauge. And then once I wipe that off, I'm also going to wipe off the tips of the tweezers. Again, just trying to clean off any contamination that might be on them. At the same time, you can drag them through this gauze pad and see if there's any burrs on the ends of them. If you do see some, you need to file those off or maybe get another pair of tweezers. But those seem fine. So the next step is to locate your strain gauges and then take them out of the package. Before I do that, one of the things I want to mention to you is that strain gauges do not have a shelf life. So what that means is that, let's say you've got a project where you need 25 strain gauges and you order a few extra, maybe you order 30. Well, you don't have to take them all out of the package. You can leave them sealed in this protective sleeve. And what that does, it helps to protect the gauges. And if you don't need them in this project, you could put them on the shelf, put them in your lab, and they'll be good for years to come. And by leaving the plastic packaging on them, then that serves as your control. So you know that the gauges have not been taken out of the package and laid on something that may have contaminated it and then put back in it. So, only open the strain gauges that you need, and there really is no shelf life associated with gauges. The other thing I want to mention to you is that this is where all your technical data is contained. So it's a good idea for you to save this information. If that means taking a picture of it with your cell phone, fine. If it means saving the package, fine. But this is where you're going to have all the technical data that you need in order to take an accurate measurement with the gauge. Things like the resistance, the gauge factor, the temperature coefficient of gauge factor, transverse sensitivity, thermal output coefficients, all of that is contained on the package. So it's up to me and you to make sure that we save that information for when we need it, because we don't need it while we're putting on the gauge, but we do need it once we're trying to connect it into electronics and take some accurate measurements. So that being said, we'll just take the plastic seal off. And I'll just open this one up. It's got another little piece of tape there to kind of hold it down. And again, keep the plastic package, don't throw it away, put it in a nice safe place so that you can document it. Here's our 3-element rosette. I'm going to take it off the little chipboard. The gauge itself is inside of a little folder to help protect it. I'm going to take the folder off, lay that to the side, maybe pull about 1 fold of wire off of it. And then this is a clean surface, so I'm going to lay that down, take the folder, lay it down. And this is an important part of this. You want to make sure that when you take the gauge out of the folder, that you lay it with the side up, which is your solder connections, and what we typically refer to as the shiny side. The shiny side's up and the dull side goes down. So I'm just going to lay the gauge down. Now, sometimes the wires will have a tendency to want to get a little bit unruly, and you can kind of move them around and bend them. You could also take something and try to hold them down. Now, what I'm going to do is use this gauge installation tape. This is our gauge installation tape that comes on this plastic roll. This is a Mylar-based tape. This is what we're going to use to prep and position the gauge on the piece of glass and then transfer it over to the cleaned hockey stick. Now, anytime you're using this tape, if it's been bouncing around somewhere in your toolbox, it's a good idea to maybe take a little bit of it and just tear it off and throw it away, because it can pick up some dust. The next thing I'm going to do is take a piece of it that's about 4 to 5 inches long, and I'll tear that off. And I'm going to use this to position the strain gauge on the piece of glass. And what it's going to allow me to do is to be able to pick it up and move it off of the glass over to the clean hockey stick. So what I'm going to do is roll it around. I'm going to use my tweezers in this folder to help hold things down. Sometimes you got to get a little creative with it to get it to not move. I'm going to take another piece of tape. I'll show you another little trick to this. I'm just going to take another piece, and since it's wanting to curl, I'm going to roll it over like that. Now that's just to hold the wires down in place, and then I'll take this larger piece of tape, and it's going to go down over top of the strain gauge. And I'm going to wipe it down in place over top of it. So the idea here is that I'll be able to pick up the piece of tape, lifting the gauge and the tape up off the piece of glass, and I'll transfer it over to the hockey stick that's been cleaned. So let me show you how we'll do that. I'll pull this hockey stick back over so that we can see it. And when we go to lift this tape, we want to lift it at a shallow angle. So try to lift it at a shallow angle. And once you get past the gauge, then you can go ahead and pick it on up. You can see I'm pulling up both pieces of tape. And I've got the gauge on the tape. And now all I have to do is transfer it over to the hockey stick in the area where I want to install it. And I'm going to tack it down at one side, and I'll just use my finger and wipe it across. And right now that gauge is in place on the hockey stick. The next part of this will be to handle the epoxy, get it ready, and then bond our strain gauge in place. Okay, so I'm going to take the hockey stick and slide that to the side, and now we're going to focus on the Embond AE10. This is a 2-part epoxy. As I open it up, we've got a jar of resin that we're going to use. This jar of resin has 10 grams of resin in it. And then we've got the Embond Type 10 curing agent. That's what we're going to put into the jar of resin to get it to kick over and get going. Along with the kit, we've got these small calibrated droppers. I'm just going to open the package. These little calibrated droppers have a graduation on the side of them. We've got 1/2, 1, up to 1.5. And then we've got the plastic stirring rod. And this plastic stirring rod is what we're going to use to mix the epoxy as we put the curing agent into the jar of resin. So to keep these nice, safe, and secure, I'm going to put them back inside the box. Close that up. I'm going to take the cap off of the resin. We don't need it, so I'm going to throw it away. And then we're going to dispense the type 10 curing agent into the jar of resin. So I'll take the cap off, lay that to the side because we will use this for other kits, other mixes, if you will, of the epoxy. Squeeze the air out of the pipette, put it down in there, draw it up. And ideally what we're looking for is about, let me rotate it around so I can see it better. In this case with AE10 we're looking for 1.5 it's actually 1.5 milliliters of curing agent. Once I'm at that spot, I'm going to take it, drop it right over top of the resin, squeeze all that in, take the dropper. I don't need it anymore, so I'm going to throw that away. Take the cap, put the cap back on the AE10 curing agent and drop it back inside the box. And then I'm going to start mixing. And with AE10, we recommend that you mix it for 5 full minutes. So I'm looking at my watch. I'm at 2:11 on my watch. And we'll need to go to 2:16. Just as you're doing this, hold the jar by the threads. That'll help to keep you from transferring any heat into it. And you just take the plastic stirring rod and kind of scrub the sides down in the bottom and just kind of mix the resin. And again for 5 full minutes. Okay, so we've been mixing the M-Bond AE10 for the 5 full minutes. It's hard to see in the camera, but you'll notice that we've got probably some bubbles that's whipped into it. I can see them, not sure that you can. But that's okay. When we go to apply the epoxy, we're going to use a little technique to help us get those bubbles out. So we're basically at a point now where we're ready to pull the hockey stick back over. And at this point, as long as we don't wrinkle this tape, the gauge will go right back in the same spot where we want it. So I'm going to lift the tape. Once I get past the gauge, I'm going to pull it back over ever so slightly. And the idea here is that we're going to apply epoxy on the bonding side of the strain gauge and on the surface of the hockey stick. So before I do that, I'm going to wipe off kind of the excess epoxy that's on the little plastic stirring rod. I'll wipe that off and throw that away. I'll get another gauze pad because we'll use it as a squeegee. And what I like to do is take the epoxy from the center of the jar, maybe let it drop once back into the jar. This is a pretty small gauge, so it doesn't take much. I'll make sure I get some AE10 on the bonding side of the gauge, and then I'll come to the hockey stick and make sure that we get some epoxy applied on it as well. Just trying to make sure that we get enough area covered with the epoxy. I'll move that to the side so I don't knock it over. And then I'll take it, pull it over, make sure that that looks good. And from what I can tell, it does. And then we'll just use this gauze pad to kind of wipe it out into place. So you're sort of using that like a squeegee to wipe it into place. Now's a good time if you've got excess epoxy just to kind of wipe off the edges. Now, once you get that in place, we're going to have to put some clamping pressure on it. So the first thing we're going to do is take a piece of silicone rubber, lay that down over top of the strain gauge. That's going to help transfer the pressure over top of the gauge and kind of evenly distribute it across that area. And then we're going to take a metal plate. This one happens to be an aluminum metal plate. We'll put that down over top. And now we're going to clamp it. And what we're going to use to clamp it is one of these Hargrave style spring clamps. The great thing about it is that it's got a spring to provide the tension or the force down against the aluminum. And whenever you're clamping epoxies, it's a good idea to try to incorporate a spring, because in particular, if you're going to elevate the temperature to cure it, if you just use something like a C-clamp, what happens is when you put them in the oven, they have a tendency to either get tight or they get loose with time and temperature due to the differences in the materials and how they expand. But in this case, we've got a spring on this clamp, and I'll just take it, position it right over top of that metal plate, try to get it in place. Try to make sure that it's in the middle, that you're getting a good even clamping pressure. And with this M-Bond AE10, we need anywhere from 5 to 20 PSI clamping pressure. And really now, all we have to do is sit and wait. We've got the epoxy applied to both surfaces. We've put down our rubber pad. It's a silicone rubber pad, the metal plate, and the spring clamp over top of it. So now we just have to wait. With the M-Bond AE10, for curing it, if you're going to cure it at room temperature, it takes a minimum of 6 hours. If you wanted to elevate the temperature with an oven, you could, and that would dramatically speed up the curing. If you take it up to around 150 degrees Fahrenheit, you can cure it in about an hour. Okay, that really concludes the gauge installation portion on the hockey stick. Once this has gone through its curing, then we'll take it out. We'll take the clamps off. We'll connect it into some electronics, and we'll try to take some measurements from this 3-element rosette. So we appreciate you taking the time to follow along with us with this strain gauge installation. If you'd like to find out more about strain gauges or the M-Bond AE10 or stress analysis in general, please feel free to reach out to us. So we've come back to our hockey stick, and now's the time to unclamp the strain gauges and see what we've got. Now, before we do that, one of the things I like to do is to check the bottle of M-Bond AE10 that we had mixed up and make sure that the epoxy is a solid inside of the jar, because if it's not a solid inside of this jar, you know it's not a solid underneath your strain gauges. So we've let it go overnight. We've got our spring clamp. I'll go ahead and take that off. Just squeeze it and lay that to the side. And then we've got a metal plate and a rubber pad, and I'll go ahead and take these off and lay these to the side as well. And now we've got our strain gauge, a 3-element rosette. It's got 3 sets of cable on it. We're going to connect it into one of our strain indicators just to see if it's functioning. Now's a good time for an optical inspection. Now is the time where you start asking yourself, is the gauge in the right location? Am I happy with its position relative to the structure of the part? And in this case, I certainly am. If that was an issue, basically at this point, you would essentially take the gauge off and start over again. We're not going to do that because I think this gauge is perfectly fine where we have it positioned. Again, it's a 3-element rosette, allows us to solve for principal strains and direction, and that's basically what we would do with the data acquisition system. Now, the next part here is I'm going to remove the gauge installation tape. It's been under there overnight. The gauge has been underneath it overnight. I'm just going to take it and start pulling it directly back on itself. If you do that, that minimizes how much force is pulling on top of the strain gauge. And once I get past the gauge, then I'll go ahead and continue and pull it on up. There's another piece of tape that's here as well that I'll take off. That was helping to hold the wires down, if you remember, while we were trying to position it on the piece of glass, and I'll go ahead and remove that as well. And just put my finger over the leads and get the piece of tape off. And again, now's a good time for an optical inspection. Is it in the right location? Are you happy with it? Does it look like it's an intimate bond down on the structure? And I think this one checks off all those categories. We've used that 2-part epoxy. It's really done a nice job of bonding it onto that wooden hockey stick. The next thing that we're going to do is we're going to add some strain relief for these wires. It's very important that you keep them straight, meaning which one is grid 1, which one is grid 2, and which one is grid 3. And if you look very closely at it, the grid that's all the way to the left with the tabs facing down is grid 1, the one in the middle is 2, and the one to the right is 3. So I will try to keep those wires separate so it'll make it easier when I'm ready to connect it into my electronics. Now the next thing I'm going to do is just add a piece of tape and I'll put on a couple of pieces of tape on this wire to help keep it from moving as we start to try to load the hockey stick. So I'm just going to take a piece of tape, and ideally we put a little bit of a serpentine in the wire. Now again, you got to keep it straight so you don't get grid 1 and 2 or 3 confused. But I'm going to add a little bit of tape and just put that down into place. I'll use more than one to try to help hold it down. Now you can see how well they're separated. So they're separated so that we'll be able to keep these separate as they connect over to the strain indicator. I'm going to take another piece of tape just to add a little bit more mechanical strength to it. These wires are very small gauge Teflon, and they have very little mass to them, so you don't need a lot to be able to hold these things down. Then I'll chase the wire back down the hockey stick a little bit further. And I'm going to put on another set of tape, maybe a couple of inches away from that. And you could use a bunch of different types of tape when you're talking about just mechanically holding something down. A lot of times we like to use our gauge installation tape for this. In this case, I've just got a piece of black tape because I think it's going to look better. I'm just going to kind of tack that down, tuck that under, and then wrap that around. And that way, if anything starts to want to pull on these wires, the tape will be there to help protect the strain gauge. And then I've got the wire comes folded up on a little piece of cardboard like this. And all we really have to do is to unfold those. I'll do that in just a second as we start to connect it into the instrument. Okay, so next we're going to add our environmental coating, and we're going to use the M-Coat C silicone rubber. It's a great environmental coating for strain gauges. It's very easy to put it on. This is a solvent-thinned silicone rubber. Forms kind of a tough rubbery coating over top of the strain gauges. A lot of load cell and transducer manufacturers like to use it because it doesn't locally stiffen the area. In this case, we're just going to use it over top of the strain gauges and a little bit over top of the wires. If you were concerned about how it was going to look, you could mask the area off to try to control the flow out of the M-Coat C. In this case, I'm not so concerned about it. I'm just going to take it and brush it on. I'm going to go up to the edge of the piece of tape, brush it over the top of that, come down along the length of those wires and make sure I get a good coating over top of the strain gauge. This, it is somewhat self-leveling, so it's best if it's on a flat surface. That's so it doesn't run off. And I'll just put the cap back on the M-Coat C. And really at this point, all you really have to do is wait on the M-Coat C to dry. Now, while it's drying, what we're going to do is we're going to connect the strain gauge into our P3 strain indicator and recorder. The P3 strain indicator is our probably one of our most popular instruments that we've ever produced. It's this blue box that I have over here to my right-hand side. It's got 4 channels of capability. It's going to allow us to take the strain gauge and connect it into it. When you're actually using a hockey stick, it's a very dynamic event, and this box is really more of a static indicator. But for us to check just overall performance of the strain gauge and to see if it's functioning, we're just going to use the P3 before we connect it into like a data acquisition system where we could take data at a much faster rate. Now, that being said, again, very important to keep the wires correct or separate, so you know which one is grid 1, which one is 2, and which one is 3. So what I'm going to do is I'm going to unravel the wire off of this one with the red dot. I'm going to connect them one at a time. That way I can keep them straight with the strain indicator. It's going to take a minute to do it. I think this particular gauge has about 9 feet of this wire that's been pre-attached. The great thing about it is that it's very small Teflon, very small in size. And once I have it off, the ends have already been stripped for us. So what I'm going to do is separate them and just connect them into the strain indicator. There's one. The red is P+, the white is S-. Sometimes you miss it. They are so small that sometimes you can miss it. And the black is going to be the D350. So now we've got the 3-element rosette connected into the P3 strain indicator. We've got 3 of our channels activated because we've got a 3-element rosette. I've also gone in and input the gauge factor for the strain gauge. The gauge factor for grid 1 is 1.86, the gauge factor for grid 2 is 1.79, and the gauge factor for grid 3 is 1.86. So I went ahead and I put that into the P3 strain indicator. If you want to see more about the P3, we got a bunch of videos on that, how to set it up and use it. But at this point, I've got the gauge factor dialed in, and right now it's active. If I push on the hockey stick, you'll notice that the output is fluctuating, it's changing as I push on it. That's an excellent indication. But what I'm going to do now is I'm going to balance it to 0. I'm going to press on this balance button and press it again. It's just making sure that that is something that we want to do. And we'll say sure, save the settings. And we're close to 0. Let's try that one more time. Yeah, so we've got a little bit of fluctuation, probably due to the fact we've got such a small gauge on a wood material. But now what I'm going to do is I'm going to start loading the hockey stick. So I'm just pushing on it, and if you watch the data, you'll see grid 1, grid 2, and grid 3. In theory, grid 2 is along the long axis, so really that should be the highest grid that I've got, and sure enough, that is showing that to be the case. I'm going to try to flip it over and do just the opposite now. So I'm going to flip the hockey stick over. And this time I'm going to press down on it so grid 2 should go high in tension. And sure enough it is. It's getting up there around 500 to 600 microstrain. I'll let it off. And now I'm going to try putting a little bit of a torsional load on it. That's going to be kind of tricky to do, but I'm going to try pushing on it. And in theory, grids 1 and 3, one would go in tension, the other would go in compression. And I think we can see that that's happening. And let's see if I can reverse it the other way. And if you watch the data, you can see that grid 1's positive, grid 3 is negative. I'm going to try going back the other way, and the opposite's true now. Grid 1 is negative, grid 3 is positive. So it looks to me, from what I can tell, is that we're getting some good strain transmission into the strain gauge off the hockey stick. And really at this point, if you look at the stability of it, the stability is pretty good as well. So basically at this point, I'd say it's passed the test. We're ready to go and hit a real hockey puck with it. And for that, we'd need a data acquisition system that could sample at a much higher rate in order to be able to capture what the strain levels are. And I would expect when one of these are actually in use that the strain levels could get quite high with this hockey stick. Just with me holding it here at the table, we got nearly 600 to 700 microstrain worth of response. That's quite a bit of strain just with a little bit of hand loading. So you can imagine what happens when it actually hits a real hockey puck, especially by a pro. But that kind of wraps up the hockey stick. We've got the S5198 installed using a 2-part epoxy adhesive. We've got the M-Coat C over the top of it that's there to help protect it. We've got a little bit of strain relief on the wires to help keep them down on the hockey stick. And then really at this point, we're basically ready to take it outside and do some impact testing and see what we get.